Okay, Algebra 2 folks, let's talk about how do I solve a quadratic equation by taking the square root. This is the second method. Yesterday we did factoring, solve by factoring. Today we're going to solve by square rooting. Okay, so you're going to need your notes and a calculator and a pencil. Let's get going. Different types of equations. All right, if you look at these two equations, you will notice the one on the left is 3x plus 4 equals 16, and the one on the right says 3x squared plus 4 equals 16. So they're very similar, but the x squared changes the way we perform the final steps. But it's also a clue to how many solutions we will have. And I did kind of talk about that yesterday with Solve by Factoring if you watched the whole video. So how many solutions will the one on the right-hand side have? The one on the right-hand side will have one solution because it's an x to the first. And the equation on the right will have two solutions because it's an x squared. Okay, so that's really important when we are discussing solving by square rooting as well. So let's talk about when we would factor. So we did the first method, we did factoring. Now we're talking about solving by square roots. If I look at these two problems, how do they differ? Well, right now, how they differ is that this guy has an x inside. It has a b term. Okay, and so if I am going to factor, I will probably factor if I have this b term. When I'm solving by square roots, I can have no b term. Okay, solving by square roots will not work if I have a b term. Okay, so we always want to make sure that we know which method we're going to at least attempt by looking at the equation and having somewhat of an idea. So in this case, if we don't have a b term, that is when we're going to use solve by square rooting. So do you remember the Pythagorean theorem? The Pythagorean theorem in geometry said a squared plus b squared equals c squared. So when you use the Pythagorean theorem, you essentially were doing solving quadratic equations by square roots. That's what you were doing. Okay, so let's do this problem and see what we come up with. So this is A, this is B, and remember our hypotenuse, the longest side, was always C. Okay, so A squared would be 36 plus B squared, which is x squared, equals 10 squared, which is 100. Now, if I wanted to solve this for x squared, I needed to get x squared alone. So I would subtract both sides by 36. So I get x squared equals 64. Now, this is where this changes, the x squared changes my last step of solving an equation. My answer is an x squared equals 64. What is the opposite of squaring a problem? Well, just like the opposite of adding is subtracting and multiplying is dividing, those are inverses of each other. The inverse of squaring is square rooting. So you're going to square root both sides. And when you square root both sides, you have to know that you get two answers. Your answers, what times what gives us 64? Well, there's an 8, but there's also negative 8 times negative 8 gives us 64. Now, in geometry, you never talked about this negative value because you can't have a negative side length. So that wasn't an option in geometry. But in Algebra 2, it is. And so in Algebra 2, the solutions would be plus or minus 8. And if you forget that plus or minus, or you forget the other solution, you have half your problem wrong in Algebra 2. So you have to remember that we're not in geometry talking about a figure and a side. We're talking about what are the possible answers that will give us a positive 64. And that's a negative 8 and a positive 8. Okay? So we are going to be solving by square rooting. And so here's the first example. Let's go ahead and write this down. 3x squared plus 5 equals 41. And we want to get x alone. And now our rules to solving, remember, they don't change. Whether I have an x to the first, an x to the second, or in chapter 5, you're going to see x to the third and x to the fourth. If I see that I have an x, I am going to try to get that alone. So in order for me to get that alone, how would I have gotten it alone if I just had an x to the power of 1? Sidebar here, I would subtract 5. I would get 3x equals 36, and I would divide both sides by 36, and I would get 12, okay? So it's the same exact way that I would do this problem that I have in front of you, except for I'm going to have to do one extra step, okay? So first thing I'm going to do is I'm going to subtract 5, okay? That will give me 3x squared equals 36. Now I'm going to take 36 and divide it by 3, and I'm going to get x squared equals 12. Now this is where I can't end like I did over here with x equals 12. I've got to do the opposite of squaring, which is square root both sides. So I'm going to get x squared equals plus or minus the square root of 12. All right, well, some of your calculators do this for you and some of your calculators don't. Just know that on tests, I never let you use the cheaty calculators. They're the calculators that when you type in square root of 12, you will get 2 square roots of 3. So you're going to have to know how to do that without those cheaty calculators. You can borrow one of mine, but you can't use yours. So let's talk about how do I get this problem, okay? How do I get the square root of 12 broken down? Well, you have to know your perfect squares. Okay, your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, okay, 144, etc. Okay, so what you're going to do is you're going to find two things that multiply to make 12. One of them needs to be a perfect square. So are there any numbers in here, 1, 4, 9, 16, 25, that divides into 12 evenly? Well, I would say 4 divides into 12 evenly 3 times. And so my plus or minus still stays out in front of these two. I can say 4 times 3 is 12, but now I know that the square root of 4 is 2. And then I would bring down the square root of 3. And so my solutions would be x equals plus or minus the square root of 3. Now remember that plus or minus is going to go out in front of the square root. It doesn't go in between, it goes out in front because my two solutions are 2 square roots of 3 and negative 2 square roots of 3. All right, so we do have to remember perfect squares and how to take the square root of different numbers. And I know you did that in geometry, so this should be just a refresher on how to do it today. All right, solving number 2. So 2x squared minus 15 plus 65. Well, again, I want to get that x squared alone, and I'm not going to be factoring because I don't have an x by itself. So I'm going to add 15 to both sides, and I'm going to say 2x squared equals 80. And then I'm going to divide both sides by 2, and I'm going to get x squared equals 40. And now I am going to square root both sides. So I get x equals plus or minus the square root of 40. Now, before I can say this is my final answer, I have to think about all the perfect squares that could divide into 40. And which one of these, if there is any, will divide into 40 evenly? Well, I say 4 will divide into 4 evenly. So I have plus or minus the square root of 4 times the square root of, what's 4 times what gives you 40? That'd be 10. So then my solutions to this problem would be plus or minus the square root of 4 is 2 square roots of 10. That would be my solutions. That would be the two answers to this problem. So it's really important that you know how to simplify your radical. And if you don't, make sure you get in for tutoring. Okay, solving number 3 by square roots. Okay, all right, again, we have an x squared and we want to get that alone. So we're going to add 5 to both sides. So we get 4x squared equals 9 plus 5 is 14. Okay, now we're going to divide both sides by 4. And we're going to get x squared equals 14 over 4. And I could do one of two things. I could reduce this to 7 halves. But what do you notice about 4? 4 is a perfect square. So if I ever get a perfect square in the denominator, I'm going to leave it. I'm never going to reduce that fraction because when I take the square root of both sides, this says the square root of x squared gives me x, and this would be plus or minus the square root of 14 over the square root of 4. And now, what would be my solutions? My solutions would be plus or minus the square root of 14 all over what is the square root of 4? 2. And if you reduce this to 7 halves, then you have to rationalize your denominator. And we will be talking about rationalizing your denominator. But if I don't need to rationalize my denominator and I can leave it as a perfect square, I am most certainly going to leave it as a perfect square. All right, now let's do another one. So here is a little bit different problem. We have 3 times x minus 2 quantity squared. This whole thing is being squared. Oops, sorry about that. This whole thing is being squared. So if this whole thing is being squared, we need to leave it until the end. All right? So we don't want to touch any of this until the end. And no, you cannot distribute the 3. Because this is an x squared. The only time you can distribute a 3 is if you have x to the power of 1 here. Then you can say that's 3x minus 6. But I don't have an x to the power of 1. I have an x to the power of 2, which means I cannot distribute. So what I'm going to do is I'm going to do this just like if I had an x squared without those parentheses. Okay, so taking it to a sidebar here, what would I do over here to the right if I didn't have an x minus 2? Well, the first thing I would do would be to add 1. So if that is if that's what you need to do over here, then that's what I need to do over here. So the first thing I'm going to do is add 1 to both sides. Then I get 3 times x minus 2 quantity squared equals 40. Okay, 39 plus 1 is 40. Now, what would I do over here once I had 3x squared equals 40? Well, I divide by 3 right away. Well, guess what? That's exactly what you do over here. Notice, from the left equation to the right equation, I do not change my rules of solving. The steps stay the same. Okay, so now I have x minus 2 quantity squared equals 40 over 3. Okay, notice 3 is not a perfect square. Guess what we're going to have to do? We're going to have to rationalize our denominator. So we're going to have to take the square root of both sides. And when we do that, we're going to get x minus 2. Okay, we don't need those parentheses anymore. So let me take and erase that little bit right there. And then we are going to say the other side is plus or minus the square root of 40 over 3. Now we need to rationalize that denominator because we can't take the square root of 40 over the square root of 3. So to rationalize our denominator, okay, we're going to do another sidebar over here. I need to move this out of the way. Okay, so to do that, to rationalize our denominator, okay, I'm going to take the square root of 40 over the square root of 40 over the square root of 3. And to rationalize the denominator, we multiply the top by the square root of 3 and the bottom by the square root of 3. And when we do that, we get the square root of 120 over the square root of 9. Oh, nice, because 3 times 3 is 9. And so that's really awesome, because 9 is a perfect square. So this would be the square root of 120 over 3. And now we can reduce the top. What are two factors that go into 120? One of them being a perfect square. So we can probably do 4. 4 goes into 120, right? How many times does 4 go into 120? I think it goes in there 30. And so the largest perfect square that divides into 120 would be 4. And so our answer here, when I bring it back over here, would be x minus 2 equals plus or minus the square root of 4 is 2, square roots of 30 over 3. And now we're not done, okay? We still need to get x alone. So to get x alone, I need to add 2 to both sides. Okay, well, I'm going to add 2 to both sides. So my answer here, and I'm going to do this in a different color so you can see what the answer is. My answer is x equals 2, because I'm going to put that 2 in front here. I'm just going to move it out in front here because it's easier to write it this way. Plus or minus 2 square roots of 30 all over 3. This is a big problem, guys. We had a lot going on. We couldn't distribute. We had an extra something here. We needed to rationalize the denominator, and we needed to get x alone finally. So this one's a pretty tough problem. But if you're needing any help, make sure that you get in for tutoring so that I can help you with rationalizing the denominator and how this process works if you're still unsure. Okay, that's it, and we'll see you tomorrow.